creating point-in-time and bridge tables with Verigen's BimlFlex. Point-in-time tables. A point-in-time table is a helper construct that joins a hub and any or all of its attached satellites into a timeline across all time slices. This table makes it easy to query a core business concept and get all attributes relevant for a given point in time. The point-in-time tables are normally created so that all relevant data attached to the core business concept can be related to an event with a specific event date time. The demo here will use the product information that was relevant at the time of a sale for an order. By storing the history of all attributes over time in satellites and combining them into a point-in-time table, it's easy to go back and query everything that was relevant at the given order date. The default BimlFlex behavior is to create temporal tables, giving timelines across all changes. The point-in-time table includes the hub and the satellite key hashes, as well as the effective from datetime information for the row in the satellite. The BimlFlex metadata for a point-in-time table is stored and viewed in the attributes sheet. A point-in-time table can either be specific for the hub, meaning all attached satellites will be included in the table, or for the hub and the specific subset of the satellites that should be included. For the connection to the data vault and the relevant object names, add the attribute key, create bit, and enter the point-in-time table name in the attribute value. Bridge tables. A bridge table is a helper construct that joins a hub to its attached links and onwards to attached hubs. This table makes it easy to query all relationship data for a core business concept and get all other attached core business concepts. The bridge table includes all connected hash keys. The default BimlFlex build behavior is to join from a hub to attach links to attach hubs and include all keys across the relationships. The required metadata for a bridge table includes the primary hub, the attached links and their attached hubs. For the primary hub, the property value is specified as isPrimaryHub. For all hubs where keys should be included, they're tagged with addKey. A demonstration. In Biml Studio, a prepared project is available with the metadata project connection. By using the scaffolding sample metadata and updating the connections to point to the SQL server used, it's possible to start importing metadata. For this demonstration, we'll be using the AdventureWorks LT demonstration database from Microsoft. The connections, batches, and project sheets are preloaded with sample metadata. By importing a subset of the data from AdventureWorks LT, it is possible to illustrate the process without crowding the demo. The demo uses the product source table and its attached product category and product model tables. To get some more context for using the point-in-time tables and bridge tables, the metadata for the sales order header and details are included. Because the end destination is a data vault, the import uses the options for creating business keys with the record source added, as well as with the relationships changed to the business keys rather than the source primary keys. The metadata import creates 5 rows in the Objects tab and all related columns and derived business keys in the Columns tab. In the Objects tab, the model object type has been populated as hub candidate objects. This will allow acceleration of both hubs, attached satellites, and relationships into links. For the products table, it's possible to split the source attributes into multiple destination satellite constructs. Adding a model grouping to the price and cost columns, as well as for the thumbnail photo columns, will allow the BimlFlex Data Vault Accelerator to create 3 satellites for the product core business concept. Accelerating the Data Vault. The BimlFlex Data Vault Accelerator provides a technical acceleration of the source tables into Data Vault constructs. In the logical view in Biml Studio, the existing source and staging tables and their load packages are visible. Use the Data Vault Accelerator options to configure the record source, connection, and project to use for the acceleration. Use the Preview DV import command to review the resulting Data Vault model. In the preview, the 3 separated satellites are visible with the model grouping name appended to the construct name. Publish the previewed metadata to persist it into the metadata model. Once published, the Data Vault metadata is visible in the Excel metadata editor. For the product source table, review that the target table and target column map to the expected hub, base satellite, and named satellites. Switching to Biml Studio, refreshing the metadata, allows Biml Studio to create everything needed for the source to staging and staging to Data Vault loads. Use the Create Table Script function in Biml Studio to generate the script needed for creating the databases and tables for the staging and Data Vault layers. It is also possible to use the generated SQL Server Data Tools project to manage database artifacts. Once the databases and tables have been created, it is possible to build the SSIS projects in Biml Studio. The build process creates a project for the source to staging load and a project for the Data Vault load. Running the source to staging load will populate the data warehouse with the current data from the source. Open the generated projects and run the source to staging and staging to Data Vault load batches. Once the Data Vault is completed, it's time to create the point-in-time table through the metadata. Point-in-time tables are created in the attributes sheet in Excel. Add the connection to the Data Vault and the hub object that will be the base for the construct. Choose the Create Pit attribute value and give the point-in-time table a name in the attribute value column. Once the sheet is set, BimlFlex will create the point-in-time object in the Objects tab. If only the hub is added to the pit definition, the pit table will include all surrounding satellites. To constrain the creation to a subset, add the satellites to the pit definition in the attributes sheet. In the example, the pit product table will include the default satellite and the price satellite, but not the photo satellite. BimlFlex uses store procedures to process the point-in-time table contents. Once the metadata has been completed, it's possible to generate the table script, the store procedure, and a wrapper batch SSIS package for the point-in-time construct. In Biml Studio, filter the table creation script so that we only create the point-in-time table. Create the point-in-time table by copying the script and running it in Management Studio. Create the point-in-time store procedure by using the Generate Scripts Business Vault Procedure Script option. Create the store procedure in the database. Build the Biml Studio project to create the batch to run the store procedure. This hooks into the orchestration and the execution is logged in the Biml catalog. Testing the point-in-time table and load process. To be able to query the data across the timeline, the source system is updated with a change to a column that is included in the price satellite. The source to staging load will pick up a change to the source. The Data Vault load will load the changed attribute into the price satellite, while the hub and the base satellite will be unchanged. In the example query, the list price has been increased for a product. The point-in-time table has not been loaded yet. In the Visual Studio project, the new batch package has been created that will run the point-in-time load process. The task calls the store procedure and logs the execution through the orchestration framework. Executing the package will load the data from the hub and satellites into the point-in-time table. Querying the point-in-time table will display 2 rows for the changed product. This represents the 2 events that has happened for this row. The key joining the point-in-time table to the base satellite will have the same data across the rows. The change satellite will have the two effective from dates representing the introduced change. To interpret the data in the point-in-time table, a query would join to the connected satellites. In this sample query, the joins are to the two connected satellites on the satellite hash key and the effective from date. The query includes some key data from the point-in-time table that is usable as dimension keys, and it joins some of the attributes from the two satellites. In the example, the list price change means the query will return a product information timeline with two rows, an effective from, and an effective to date time for the rows. Creating bridge tables. The bridge table connects a hub with its links onwards to the connected hubs. The bridge is defined in the attributes sheet in Excel. Add all required hubs and links for the bridge. Use the attribute key createBridge and specify the name in the attribute value column. A bridge table in BimlFlex has a primary hub specified and can optionally add the keys for the attached hubs. For the product bridge, the metadata includes the main product hub, the two product links, and their attached hubs. Once the metadata is completed and the sheet has been set, BimlFlex adds a bridge object in the objects sheet. As with the point-in-time table, use BimlStudio to create the table script and the processing store procedure script. By building the project in BimlStudio, another batch is added to the Data Vault load project. This is used to run the load of the bridge constructs. Use BimlStudio to create the tables and store procedures to load the bridge table. Build the Data Vault load project in BimlStudio to create the bridge load batch. Open the project in Visual Studio and run the bridge load batch to populate the bridge table with data. Querying the bridge table using Management Studio can identify a single relationship row for the product with ID 680. The bridge includes all keys required to join from the bridge table to any relevant satellite or point-in-time table. By expanding slightly on the existing model and adding a second bridge table, it's possible to join the sales orders to the products more easily. This would allow tying the sales order data to the product attributes at the point of sale. In the attributes sheet in Excel, there is a second bridge definition added. This bridge spans the sales order header, details, and the product table. Loading and querying the point-in-time and bridge tables. To illustrate the usability of the point-in-time and bridge tables, the data warehouse will be loaded with data from the AdventureWorks source. A change will be introduced to one of the products so that it can be interpreted as changed over time. To begin with, the data warehouse is empty. Neither staging, data vault layer, nor point-in-time tables have been populated. Initial load from the source will read all available data from the source to staging and persisted staging. By introducing a change to the product with ID 680, this row will be added to the data warehouse on next load. The introduced change is for a specific attribute that is only used in a single satellite. The load pattern will add the change row to the affected satellite. Any other satellite will remain unchanged. After rerunning the load with the change, the data vault will include the added row in the affected satellite. Querying the data warehouse for the product with ID 680 will illustrate the added row to the price satellite. Once all data has been loaded to the data warehouse, it's time to populate the bridge and point-in-time tables. Running the two batch SSIS packages will process the bridge and point-in-time tables. Once the two batches have completed successfully, it's possible to interpret the point-in-time and bridge table data. A point-in-time table query normally joins from the point-in-time table to the relevant satellites to create a timeline for the attributes in scope. This query can be reused as a virtual dimension or as a source view for persisting the data into a dimension table. Querying the bridge table will display the data for the product with ID 680. Querying across the bridge and point-in-time tables can create a connection from an event to the relevant product information that was valid at that point in time. In this case, the query will gather the product information that was current at the time of sale. By using the order date from the sales order header satellite and joining through the bridges to the point-in-time table, any product information would be joined for that specific point in time. This concludes the point-in-time and bridge demonstration.